All right, so when we talk about energy, we rarely talk about absolute energy. We usually talk about change in energy. And so that's what this triangle means. This is a delta symbol, and it just means change, right? So this is change in energy, right? So when this ball goes from up here to down here, we have a change in the energy. And it's generally useful to calculate the change in energy. It's generally not useful to calculate absolute energy, right? How much energy does this ball have in it? It's really quite a bit of a loaded question because there's many different forms of energy and the vast majority of which are not accessible to us. For example, in the nucleus, we have the protons and the neutrons attracted to one another. There's a lot of potential energy that's keeping them together, right? But we can't use that on our, everyday basis. So most of the energy of compounds is not accessible. And so when we talk about chemical energy in chemistry, what we're talking about is energy stored in bonds. For example, like a carbon-hydrogen bond going to something like a carbon-oxygen bond. A carbon-oxygen bond is more stable. So if we put energy here, reaction here, and we go from a CH bond to a CO bond, you can see we release energy. And so this will be a negative delta H or a negative delta E. We're releasing energy to the environment. In terms of the change in energy, it can be quantified as two main things, as W or Q. So W is work, right? So something can do work, and that's a form of energy, right? Anytime something that does work, it itself is going to lose energy, right? That kind of thing. And then Q is heat. Right, this is what's going to be our focus. Right, if something feels hot, the fire is hot, it's releasing energy to the environment, that kind of thing.